Just a short check-in to show you the state. And relative to last time, made a lot of progress. I didn't think that I would invest this much time, since this is practically like a side project, but I did, and I wrote the first iteration of the CPU, and it is technically a CPU at this point. And it works. I really wasn't expecting that I would just do it. I've been planning like half an hour every day or an hour because of work and stuff, but here we are. So it's running a program now. You can see it here. This is the program. It's an infinite loop, and the logic on it runs. Hold on, let me focus it. It's having trouble in the dark. So the logic running on it is based on my own ISA. In the previous video, in the intro video, into the what I called the DLU, or Dangling Logic Unit. It's basically what I call my CPU. I said that I would write my own ISA because I wanted to make it very simple and straight to the point, just the basics for what I wanted to do. So I did that, and I wrote a brief definition of it in Sail. Then I generated some tests. Sail is very good for this. You can generate a bunch of tests. You can generate an interpreter in which you can try your instructions. And I did that, and then I decided to write the Verilog for it. And this is the loop. I can briefly show you the core. This will eventually be open source, but right now I don't want to, because it's too early. I don't want to, show anybody. I'm still learning all of this, and I don't want to, I'm kind of embarrassed in a way, to be honest. So that's just a quick look. And I'm currently working on, well, I haven't started yet, but I'm planning on getting started with, come on, focus. Anyway, there we go. I'm getting ready to start with an assembler, just a very basic C assembler with no label support, no imports, no includes, nothing like that. And then I'm gonna test it out, because right now it's kind of tricky to write the instructions in hex, like raw, like this. I have some helpers that I wrote here so that you could see what is happening. I have 15 plus 1 instructions. I added one since the last video, so in total 16. These are just a couple. So this is what it does. You can probably read that relative to that. With the spec, you would be able to read it, but that's not ready yet. It'll also be published hopefully soon enough. So this is what's running right now, and what the assembler will do, it'll take this input here and convert it into this, and then I'll just from Verilog, I'll read that before the bit stream gets generated. It'll go through all the stages, synthesis, everything, and then it'll get written here, and it'll execute. Effectively, it'll be like this. But what I am going to write is only this. The assembler will convert it into this, and then Verilog will read it, or Vivado technically will read it. So that's the plan now. And then it'll be much easier to write real programs, because this like takes time to get right. But actual programs, and I want to do something basic first, and then we'll see. I might print something in hex on the 7 segment there. There are 8 7-segment displays, so might print something there. I'm still learning how they work. Anodes, cathodes. It's kind of finicky, so I'm still learning how to display the right symbols there. But that's also on the roadmap. And after that, something more complicated. I would like to start porting my kernel as soon as I can. In the other playlist, also on YouTube, you may have seen that I showed my kernel here on the portable. It's kind of dark here, but you can probably see it a little bit. So I can currently run my own kernel from a diskette that's in here right now, and it works. But I want to get it to run on my own CPU now. I'm gonna start calling it DLU, just so you know, because that's what I chose. So DLU, and the architecture is MISC, because we have CISC, we have RISC, and this is even more reduced than RISC. So I decided to call it MISC, as in minimal or minimum instruction set computer. I think it's pretty accurate. To, you know, there are 16 instructions, so just the, you know, bare basics, and that's intentional. So I would like to start porting, and I'll start with, well, I need to write some sort of a BIOS, some very basic implementation, and after that a bootloader for the kernel itself, and then some utilities after that. We'll see. I currently have a shell that runs here successfully on physical hardware, but it'll be more tricky to get it to run on this, so that'll take a bit longer. But yeah, that's approximately what I want to do. So this is just a quick entry. I'm gonna show you more in the upcoming days. I still need to debug some issues here, but I'm thinking that maybe in 2 days or something like that. This was just a quick, I didn't even want to record a video today, but then I thought about it, and I was like, yeah, you know, might as well document this checkpoint and talk about it a little bit. The red LED that you see flashing, see, that is memory write. So when it's not flashing and you see the LEDs here flashing, those are register writes, and when the red LED flashes, that's a memory write. So just so you know. But anyway, yeah, gonna make another entry in a few days. See ya.